Okay, we will be talking about networking models. What are they, how they work, and how they are built exactly. So, before we get into that, let's get some basic definitions down first. To understand a networking model, we first must understand what is a network and what exactly is a network model itself. So, a network can be defined as collection of autonomous systems. So let's say I have a bunch of computers here or a bunch of nodes in this case, and they have some form of link between them. And using this link, they are able to share resources, information, data, whatnot. So this essentially is a very rudimentary network. Now, based on that definition, you can get a good idea of what a network model might be. A network model is essentially a blueprint for what? For building networks. Uh, Networking model is essentially the rules, the standards that we have to follow while building a network. So there are two main networks that we need to concern ourselves with. One being TCP/IP and another being the OSI ISO model. So let's start with that. Uh, in networking, there is a very important concept that we must be familiar with, and that is layering. Now, the name is pretty self-explanatory. Layering is it's like a chocolate cake. Each layer has some purpose. They are all independent of each other, but they are each one of them is necessary for the thing to work as a whole. So for the like I said, like a chocolate cake. So at the bottom you have the bread, and then you may have a layer of cream on top, and maybe some sprinkles, and maybe some more cream, whatever. So layering in networking follows a similar principle. You have separate layers, each with an independent function. However, each layer is dependent on the layer below it for the transmission of data. So, layer by layer, you transmit data and it gets wrapped around, it gets encapsulated. We'll cover that in a bit. And this is a very effective way for designing network models because this allows us to debug. Each layer is an independent process, so we can isolate the problems. And scaling is easier because scaling is just a matter of increasing the layer size vertically. Okay, so with that, now let's actually cover a model. So OSI ISO model. Now this is a very old model, released in about 1978, I think. And it is not a model that was made for practical applications. The model itself is purely theoretical and we don't physically implement it anywhere. But either way, it has seven layers, each with its own unique responsibility. So we'll start from the bottom. At the bottom here, we have the physical layer. And our physical layer is the actual hardware implementation. This is where so the physical layer, this is the actual hardware implementation of our networking model. This is where the cables, the fiber optic cables, the Wi-Fi, the radio waves, this is where all of that is implemented. The layer itself does not know the data it is processing and transferring. It's like the roads of a car network. The above physical layer, we have the data link layer. Now, this is responsible for the node to node delivery of the message. The main function is to make sure that there are no errors while transferring. So, whenever any data is transferred from the physical address to the data link, it searches for the required address using its MAC address. And then, based on that, it ensures that data is transferred to the required node. Then we have the networking layer. The network layer is works for transmission of data from one host located in different networks. So essentially, it finds the packet routes, the shortest route to transmit from the n number of routes available. So if we have a bunch of networks here, a bunch of nodes here, there are a bunch of possible paths from this to this. So the network layer chooses which path to go through and which path is optimal for current use. Then we have the transport layer. Transport layer is essentially it's not used in uh, all protocols, but it is for acknowledgement for successful transmission. So in case such as in the TCP protocol. So in TCP protocol, in case there is any data loss, then it can be retransmitted, and that is the main function of this layer. In case uh, there is any data loss, it will identify the loss, it will transmit the data again, and has to receive acknowledgement for the transmission of data. Then we have session layer. This layer manages the sessions, the connections to other nodes. So synchronization, something like synchronization between two systems. Suppose you have two systems where one is a lot more slower than the other. There's an outdated system, now it's a very old system. So the synchronization, the session layer is required for synchronizing the communication between them. The rate of communication should be the same in both cases and should match the one with the slower rate. Then we have the presentation layer. Uh, so after all of this data transmission is done, the data itself needs to be in a usable format. So after all that, maybe you have some string of binaries, but this itself is not usable by any application. So the presentation layer essentially takes this binary and it converts that into a usable format. So that may be a JPEG file or an MP4 file or TXT, anything. And then finally, we have application layer. This is what interacts with the uh, host program itself. This is where the application logic is implemented. This is where different protocols are implemented, like your SMTP protocol, DNS FTP protocol. So that covers the basics of an OSI model. Again, it's a theoretical model. There is no real application for this, but based on this model, TCP/IP, which is the most widely used one, was developed. Okay, so now there is another concept in networking that we must understand, which is encapsulation. Encapsulation is it's a very simple concept. Essentially, the matter is with each layer, the data passed on with each layer has something added to it. Now, what exactly does that mean? So, for an example, let's say the session layer in our OSI model. The session layer sends some data to the transport layer. The flow of data is in this direction, right? So the session layer sends some data to the transport layer. So the transport layer data will be broken up in a different piece. It might add some headers to the file itself, which might contain some information for the location where it is supposed to go, the destination, some metadata, anything. There's a lot of things that will be done here. So encapsulation essentially with each layer, the data is encapsulated with another layer of data. Now we finally come to TCP/IP model. This is the most important model there. Uh, this is generally considered the backbone of modern web. And as you can see, unlike the OSI model, which had 7 layers, this only has 5 main ones. Uh, in exchange for this, each layer has more responsibilities compared to the others. So TCP/IP, the application layer is the highest layer. It's the one closest to the user. It acts as a bridge between the local host and the networks, local program and the network. So something like your browser or your your some mail client or some file transfer. There's a lot of things. So something like that and your actual network. Yes. So application layer acts as a bridge between these two. Then we have the transport layer after the application layer. The transport layer, it has a similar function compared to the OSI model, but it has some additional functionalities. So here we make two major distinctions, and that is between protocol used here. So here you can make use of the TCP or the UDP protocol, both very well known. So both of them have their own use case. TCP is generally considered more reliable. Uh, it's used in when your data is there's an order or it's sequenced. Data is sequenced, and there's very little data loss because there's confirmation for data receival. So in case there's any data loss, you can request for the data to be retransmitted. Now compared to TCP, UDP is a lot more unreliable. There's no order, there's no sequence to the data being sent. There's no confirmation for receival either. Generally, which is why TCP generally is preferred over UDP, but they both have their test cases, their use cases. Then after the transport layer, we have the internet layer. Now, internet layer also it's used for routing data across different networks. So it essentially handles where the data goes. If the transport layer is how it goes, which protocol, then the internet layer is where the data will go using that protocol. So here you make use of things like your IP addresses, your IPv4, your IPv6, the IP protocol, or your ARP protocol, determine your destination device. Okay, and then finally we come to the network layer. Now this is where the hardware implementation comes once more. This is the lowest layer, and this is where your IP, the packets from your internet layer, they are wrapped into frames, and then these frames are transmitted using your physical MAC address itself, and then whatever your medium for transmission is between the nodes. Your you have some cable or some there's Wi-Fi, whatever it may be. And that brings the end to TCP/IP.